Hello everyone, uh, welcome to part 2 of making your own Honkai Star Rail private server. As just like the Telegram poll, Python won, so we will be using Python and we will be setting up the development environment first. I will be using UV. You can just, oh yeah, all of the links will be in the description below, so you can just open it easily without typing manually. So you just have to open this link and then get the installation. Choose your operating system. I'm on Windows, so I can just do this. So just press Windows plus R and then type in cmd, paste the script and then enter. While that's downloading, you can go to like protobuf repository and /releases. You want to like scroll down and find proto-c. So proto-c, version, operating system, and then the CPU architecture. Mine is 64-bit, so I will be choosing this, Windows 64-bit. But I already have it downloaded, so I will not download it again. And then for the text editor, you can use whatever you want, but I will be using VS Codium, which is a fork of Visual Studio Code. Basically just choose one of these, whatever you want. I recommend just downloading this. .msi updates disabled if you're on Windows. And then we want the midterm proxy. In the middle proxy, we will be using Fiddler Classic. You can just type in like a fake email in here and type whatever country you want and then just download. I already have this installed too, so I won't be installing it again. UV has finished installed, okay. So there is two things that you need to do though before we start on the coding. And let's say you have downloaded the protobuf, yeah. You want to right click this and then extract it to whatever really. What matters is you open this bin folder, click on this so you can copy the path, and then you want to search for environment, and then this menu will pop up. Click on this and search for this variable path. You edit that and then you can type new and then paste that. As you can see here, I already have one, so I will just delete that. Basically just add it to the path environment variable. To confirm if you did it correctly or not, just open cmd and then type in proto-c. If you did it correctly, this should show up. Let's close that. And then you want to open Fiddler. Let's say after you install it, right? You want to go to here, options, and then HTTPS. You want to capture, decrypt from all process and ignore. When it asks to install a certificate, just say yes. So now that we have set up our development environment and the text editor, let's say you also install the same, so you can just press Ctrl-KO. And then you want to make a new folder. I will be making it here. I'm just going to call it Honkai Star Rail private server. And then select folder. Of course, it's still empty as you can see on the file explorer over there. You just want to press Ctrl backtick to open the terminal, and then you can type in UV in it. This will set up the project. You can just delete the main py. We don't really need that. So we will make a few folders. So first is the secret server, game server, and then we will also have the proto. For the protobuf, you can just copy it from my GitHub repository. Okay, so this is the repository. You can click on the version you want. Right now, the production version, aka the live server for Honkai Star Rail, is 4.0, so I will be choosing this. And then you want to copy this to file. So you will just go to raw, open that raw, press Ctrl A and then Ctrl C, and then you can paste it here. New file, cmd id.json, paste that and save. And then we can also copy the proto. Okay, or you just can just type this really. It's the same thing. That's much faster, yeah. Okay, and also paste that here. Okay, now you have the protobuf and the command ID, which is the first step, yeah. Okay, now that you have copied the proto files, we want to like add the dependencies in UV. You can just do this. if we add and then type the things we have to add, which is better proto 2 compiler, better proto 2 all, and then face API, and then UV corn. It will automatically add everything and set up your Python too, so that's very nice. Now to the proto, you want to make a new file called cmd.py. You can name it whatever you want. I just prefer naming it cmd.py. So what we want to do here is load this JSON into the Python code, which you can do by using the built-in JSON library. So import JSON, and then you can open the file cmd.id.json r, and then you can like encoding utif8, and then you can do like command name to id json.f. Now we want to make the opposite, but you don't actually have to. This is just something for debugging. So command id to name equals value key for key value in command name to id items, I think. Yeah. So what's happening here is we are making something like this, but the opposite, so we get the number, and then we use the number to get the name. And as you can see it here, value key from key value in this thing. Yeah, I'm bad at explaining, but that's pretty much it. And then to make it nicer, you can make a class. I will name it cmd registry. Here we will define a static method. A static method is a method in a class that doesn't actually rely on the class. You can annotate it like this. It's not really necessary, but it's just nicer that way. And then we can use the walrus operator to get something from something like this, or the command name to id. There is like two syntax you can do. You can do like command name to id like this, or you can also do like this. Hold up. We will be using this one because it's just more proper. So we will do this: get command name to id, get name. The name is from there. So, and then we will just return it. Otherwise, we can just erase an error, which is value error. Invalid cmd name. We can just do this. And then we will make the opposite method, which is to get the name. It's very nice. Okay, that's pretty much it. Okay, now what we want to do is make our HTTP server. It will be under SDK server. You want to name the file __ main __ py. You have to name it this so that you can just do this. If you don't do that, this won't work. Okay, so what we want to do is make a basic HTTP server first using face API. So we can just do this. Oops. Why did it do that? Now what you want to do is, for example, let's make a get request, get root. So you can just do this, and then okay, that's basically a basic handler and router in face API. Now we want to run the server itself, so we have to do this. UV corn run at host. Let's just do this ports. Okay, so what's happening here is we are importing the face API class, and then we are making a variable with it called app, and then we make a function called handler thing, and then we decorate it with app.get, which means this function will be called when a get request happens to the test route. and it will just return a hi. And then we run it using UVcorn. Oh wait, I haven't imported UVcorn. Oops. And then UVcorn run app, which is this, and then host. This 127.0.0.1 is basically local host. It's your own computer, and then port can be whatever you want, but I will be using 21,000. So let's try running the server now. Now you want to open CMD. I guess it's to test the HTTP server. As you can see, it's now running. To test it, you can do like curl. You can just do this actually. Okay, see, it works. As you can see, it locks the request and then we get hi. But as you can notice, there's a quote around here. We actually don't want that because Fast API by default treats every request like a JSON. So to fix this, we have to import from Flash API, import plain text response. Wait, this for I forgot something. Responses. Now we can do this. Before we save this, let's run the curl again with v. As you can see, the content type is JSON. But now if we do this, plain text response, hi, and then restart the server, and then do that again. As you can see, the content type changed to text plain, which is what we want, and the response no longer has the quotes around it. Okay, now before we finish the HTTP server, I will show you how to sniff. So basically just open Fiddler and then you can launch Honkai Star Rail. Oops. Okay. As you can see, when you open Honkai Star Rail, there are a bunch of requests, like you can see Hoyoverse clearly here and many more. It will show up on Fiddler. As you can see here, query gateway, RPG global, and MA passport token, that's the login. Now let's assume you have a look at the request and stuff. You want to import the protobuf here. What we need is get server, dispatch, and region info. Let's delete this handler and create the actual first get handler, which is query dispatch. This will be a plain text response. Some of them will be JSON response later on. We'll just do that there. Oh yeah, the function name can be whatever you want. It's not affected by the root or anything. Like even if you rename it to be something like this, it will still work. So what really matters is the root above here. So for the response, we want to do RSP dispatch, and then we want to make the region list. Oh yeah, for the how to know what to put in the proto, you can just like open this and then like dispatch. Oops. As you can see here, there's like region list and much more. Oh wait, I forgot to compile the protobufs. Oopsies, give me a bit. Okay, to compile the protobufs, you want to do this: uv run protoch and then /i dot / python better proto2 out. The output will obviously to our proto folder, so just type in /proto, and then the proto name is game proto, and then you can just enter that. To make this easier in the future, you can like make a batch file. A batch file is something like this. So basically you can just do this. So instead of having to like type in all that all the time, you can just type in this and then enter. But I will not do that for now because, well, we are already running this. Okay, now that the protobuf has finished compiling, we can continue with the HTTP server. Let's take a look at the protobuf again. Region list. It's repeated. Repeated means a list basically. So we want to do this. We will have multiple region info inside of it, and then we will see what does region info has. It has name, title, dispatch, and type, and many more. So what you have to fill in is just the name. So I will name it my server, and then title also my server, and then m type I will be using 9. Oops. And then dispatch URL is also very important. So what you want to do here is HTTP and then your own host and port, which is like this, and then slash query gateway. You might be wondering why isn't the rest filled up, because it's not used. Well, it's not really important. Also, the thing with protobuf is that if you have a field that is of string type, this is a string type. If you don't fill it in, it will be automatically filled in like this. If it's a number type, let's say we have like ID, something like that. If you don't fill it in, it will automatically be 0. But if it's like something like this again, if you don't fill it in, it's basically not there. That is how protobuf default fill works. Okay, now that we have RSP, what we want to do is import base64. There you go. We'll just do RSP bytes. Oh yeah, before turning it into base64, you need to turn the protobuf into bytes, which you can do by just doing this. And then, oops, RSP. Now we can just return the response. Plain text response RSP. Let's try this. UV run SDK server. Oh, it's a typo. Okay, there's an error. Oh yeah, there's also a typo over here. Okay, this should work now. Let's open CMD again. Let's try curl localhost and then our port query dispatch. Okay, perfect. This is base64. Let's confirm that it actually changes when we actually change something in here. Let's say we do that. Restart the server. Do it again, and yep, the response changed. Okay. Now that works, let's get to the next handler, which is for query gateway. Oops. Oh, misclicking. I will skip over this. It's basically the same as this, but with a different protobuf. Okay, we now have a query gateway. IP is just localhost, that's fine. And the port, make sure it's not the same port as your HTTP server, because otherwise it cannot run. And then these three things, you can get them from the official server. If you are playing the live server, you don't have to fill this, but if you are playing the beta version, you will have to fill this. You can get them just from making a request to the official server. And then iFix version is always 0. Use TCP is also important because we will be using TCP for the game server. And for the rest, it's just a bunch of random things that doesn't really matter. Basically, these are just like copying the one from the official server. Okay, I've added the rest of the handlers. These are for like the login and stuff. If you change the env type, this will be different. So that's why I'm using env type 9, because that's what I'm used to. For the first one is this one, Honkai RPG MDK Shield API login. You can put in anything you want for the email, UID, token. It doesn't really matter. Just make sure. This one is for the Shield API verify. And then okay, so as you can see that most of the handlers are hard-coded, which means it doesn't change at all, no matter what. The reason why I do this, besides the fact that I'm lazy, is that to actually handle login, you need to use a patch for the game, because the request for the login is encrypted, so you cannot really process it without patching the game. That's pretty much it. Let's try running it now. Okay, perfect. It runs. Okay, now that the server is running, you want to open this link and copy this script for Fiddler. So open Fiddler. If you use a different port, just change it. Open Fiddler script, paste the script, and then click on Save Script. Now what you wanna do is open Honkai Star Rail. As you can see here, we are getting a lot of requests. Don't worry about the not found ones, it doesn't really matter. As you can see, the SDK server works. Now, if you have reached this screens, if you have reached this screen, it means the SDK server is working properly. If we click to start right now, it wouldn't work because we don't have the game server yet, but let's just click it anyways and see what happens. It will take us back to the start with an arrow. Let's see, okay. So now we have confirmed the SDK server works. Amazing, right? Okay, now we will be moving to the TCP server, which is the game server. Just make a new file like this. And now we want to import async here, and then let's make the handler function, which is async dev. You can name it whatever you want right here, and then in here we will just like take 6 bytes from the data, so you can do like this, select 6 bytes. Now we will print like just do that, and then we can just close it immediately. Now what you want to do is make another function, server equals await async here, start server. Oops, this is the wrong one. And then you can type it the function here. It's called handle, so just type it handle, and then the host and the port. Make sure this is the same as the one in SDK server in the query gateway. This has to be the same with this. After that, async with server, await server, serve forever. Now if name equals main async one main. Okay, now let's try running this. UV run and game server. Okay, it's running. I forgot to add like a print. Hold up, let me just. Let's do that so we know that it's actually running. Now that our game server is running, let's start the SDK server. If you run SDK server, now you can open Fiddler again. Okay, make sure the script is there, yeah. And then you can launch Honkai Star Rail. Now click to start. Okay, now we have the bytes that we read from the game. Basically it's 6 bytes. How to properly decode this is you want to look at the packet structure of the game. So the first 4 bytes is the head magic. The next section is command ID, which is 2 bytes. So let me show you something. Hold up. You can copy paste that and then here. So this first 4 is the head magic. This is the command ID. We don't really care about the head magic besides comparing it with the actual head magic if it matches or not, but we care about the command ID over here. So to get the actual number, you can just do this, and it says 38. You can go to CMD ID JSON and search for 38, and there you go. Basically the packet that we just got is a player get token CS rec, which means we have to respond with a player get token SCRCP. Now that we have learned a bit about packet decoding, let's make the module for it. Let's name it packet py, and then in here you want to import struct, and then you want to define the head magic, which is p x9d, x74, x7, and then x14, and then we want the tail magic too, which is p xd7, xa1, and then x52, and then x8. Now we want to make the class for the packet. This will be the boilerplate, part. You want to do slots, cmd, and then oops, head, and then tail. You don't have to do this, but it's just a good practice to do it. And then we want to make the constructor for the class. Let's forget about types for now. Okay, this is just so that if we don't pass anything for the head, it will automatically be an empty byte. And then do the same with body. Self CMDs, self head, self body. Okay, the boilerplate for creating a Python class is done. Now let's make the decoder. So we will do async def with from. Alright, CLS is a special keyword for a class. It basically just whatever. I don't want to explain that. You'll see after. They want to take the reader. The reader is from here. So we will be doing something like this, but in the packet class instead, so that it's not that messy, you know. Oh, as I was going to be erased. Okay, now let's try to read the first 12 bytes, which is header data. Oh wait, reader, read exactly 12, except, oops, async, you know what, I'll just do this. Yeah, I'm a bit lazy to do proper error handling, so we'll just do that for now. Now we want to check the head magic. The reason why we read 12 bytes is 4 plus 2 plus 2 plus 4 is 12 bytes. So instead of doing like 4 reading, we can just do 1 reading for 4 of this. So now we can just compare it by slicing the header data. Take the first 4 bytes and then I guess you can like raise, but I'm a bit too lazy for that. Okay, we've checked the head magic. Now you might be wondering, how do we decode the command ID and such? Because previously we have to type it manually. So to do this, you have to use struct. So let's say we want to get CMD, then we just do struct unpack from, and then greater than H capital. Greater it means big endian. If it's this, it means little endian. And the letter after that is the type of the number. So H is U16. I, if I remember correctly, it's the 32. Yeah, this is basically the type of the integer. So unsigned 16 bits, unsigned 32 bits, and such. You can just read the documentation of struct. I will recommend reading the documentation of the things you use. It's much better than like blindly relying on AI and all that things. So now we can pass the header data, and then we can pass the form. Yeah. The reason why this is 0 is because you can like unpack multiple at once. So this will be returning like multiple. But in this case, we only return one. So we'll just take the first item, and then headline struct unpack from header data, and then we want to get 6, and then we do body length struct unpack from I header data, we do like 8 and then 0. The number here is like the index of where it starts unpacking. So if we took the first 4 bytes, then we want to start at the next byte, which is the 5th byte. and then we want to like uh, buff wait reader read x exactly. Now we want to just read like head length equals body length plus 4. 4 is for the tail magic, so we will get like head equals buff take the until head length, and then for the body we can take like from head length until head length plus body length. And now for the tail we can just take the last 4 bytes like this. There you go. Accept. Let me just do that. I don't really want to do some proper error handling now. And then we can just check if the tail matches or not with our tail magic. Okay, now we can just return class. So basically when we do this we are calling the init function. We can just do cmd equals cmd, head equals head, body equals body. Yeah, that's pretty much the packet module. Now that we have like the decoder, let's make the encoder. So you can make your own custom something like this, but I recommend just doing this like that. Oops. Okay. The reason why this is different is so if you do the if you make your own self function, you will have to do something like this. But if you do this, you can do something like this. This is like a built-in function to convert strings into bytes. It's kind of like traits in Rust, I guess. I don't know what to call it really. I'm not really familiar with Python. So to do the encoding, we just do the opposite of decoding. So we want to get the length first. So head length equals length self head. We will get in from this, yeah. And then body length self body. So now we will calculate the total length of your packet. So we get like 12, which is, as you can see here, 12, and then plus head length, body length, and then plus 4 bytes for the tail magic. Now let's create the buffer for the packet. We'll do this byte array total length. Now normally you can just do like slice it like that, but it's not that efficient. You can use something called a memory fill. Now this is where the encoding starts. So fill magic, and then struct back into h fill for self cmd. So this is like the big endian, and then this is the buffer, and then this is the index, and then this is the data you want to pack into. And as you can see, it mirrors the one in here. Hold up, just do the same for the rest. Oops, what the thinking? H fuel, and then oops, why did I do that? Headline, and then struct back into fuel 8 body length. Now we want to type a variable for now. This is to make it easier. Offset is 12. If the head length is over 0, which means the head data is not empty, we will put it in offset until offset plus head length equals self head offset. So basically, if the head length is empty, we won't be encoding the head data. And what this do is basically offset will be plus head length after you encode it here. Now we will do the same with the body length, and then do the same again. Body offset. Now for the last part, which is the tail magic, you can just do this offset until offset plus 4 equals tail magic, and then you can return bytes buff. Okay, now we have the encoder and decoder. Okay, now that we have made the packet class, let's import it here from dot packet, import packet, and then instead of using the reader directly, we will use packet read from reader. Oh wait, don't forget to await because it's an async function. I think I forgot something. Oh yeah, this must not be a sync. It doesn't have to be a sync either. So let's do that. Now we can just print data cmd, print data body. We don't really care about the cmd. Now let's try sending back a response. So we know that the first packet is player get token csrec, so we want to get a player get token strcp from import player get token strcp from product cmd, import cmd registry. Now we want to like write back the data, so let's try to make a response. Player get token crcp. Let's check what's in there. Okay, so there's the UID. We don't really care about the rest, they're not important for now. UID, and then you can turn it into bytes. Now we want to make a new packet. CMD is CMD registry get ID player get token RCRCP, and then we want to the body is just the RCP. Hold up, let me close this. Okay, now we can just do like packet, also turn that packet into bytes. Now we want to write back the response, which you can do by doing this writer write packet, and then writer drain. Okay, that's all be good. Let's comment this out for now. We don't want to close it. Okay, actually I did a typo over here. This shouldn't be tail, this should be body. Now let's add a while loop over here. So you can just select that and then press Ctrl square bracket right. There you go. And then add like while true. This will keep, so the server will keep on reading the packets. Otherwise it will just read once and then it doesn't do anything anymore. Now let's start the server. I'll make sure the SDK server is also running, and then you can start the game. Okay, oops, let's close that for now. As you can see here, our first packet has the CMD ID of 38, which again was the player get token CSREC. And then we send back a response, and then we got 57. 57 is player login CSREC. If you manage to get a packet after sending back one, so like let's say you get the first request, you send back a response, and then you get a request again. If that happens, it means your server is proper. It means the packet is correct. So you can just focus on making the server better now. Okay, now we obviously won't always know the order of the packets or how many of them we will get. So we have to route the packet somehow. There are two methods that you can use. You can use like a match case. So like you can do like CMD and then like something like that, I guess. Or you can use a map. So you can like do something like this. CMD, then like that. We will be using a map instead because it is more efficient on languages like Python. Okay, now that we know how to route the request, let's move the handler somewhere else. So let's name it handlers. I will make a file called player.py. Basically, we will move the things for the player get token here to here, like that. And then we can just remove this. So now what we want to do is we import the function from here, so you can just do from handlers player import on player get token. Now we want to make the map. Let's call it handler map. cmd registry get id player get tokens, yes, right. And then we will pair it with the function which is on player get token. Now in here we will do like if handler map get data cmd. We will just do await handler and pass the writer, because in here we just take the writer, we don't need the reader here. And then we can just else print f unhandled data cmd. Okay, now let's try running the server again. So let's try it with the game. Okay, good. This works. Now what we want to do is make the rest of the handlers that is required to get into the game. So to get into the game you will need these handlers. I will type in the cmd for now. These are the handlers that we will need to get into the game. But before we make the handlers, we need another map which is called a dummy map. So this is for the request that is not needed to be handled. So you can just send back an empty packet. One of them is like get skin map info. You don't need to handle this. So instead of pairing it with a function, we can just pair it with another cmd id. Get skin map. So this will be the strcp and this will be the csrec. So for the dummy map, what you want to do is add here elif dummy rsp dummy map get data cmd. We can just do like hold up, I forgot how to. Okay, bucket cmd equals dummy rsp. And then we can just bucket bucket, and then we can just writer write bucket, and then await writer train. That's pretty much it for the dummy handler. Okay, I added a lot of things off screen. So I added like on get avatar data and on player heartbeat, and I also added the code and all of that. For the dummy map, I made it easier to modify, so it's something like this now. I will share the source code so you don't have to like type this one by one. I also changed the handle function. So now the while loop is in a try except block, so that when you disconnect from the server, it doesn't stop. What else? Oh yeah, this I also use get name, so that when you don't handle something, you can see what's the name of the cmd without having to open the cmd id JSON. Okay, let's look at the handlers now. Oh yeah, I also changed this, the handler. Previously we only give writer, now we give data body too. Let's look at mission.py. So this is one of the reasons why I need the body. We want to parse the request, and then we send the response. What's basically happening here is that we are telling the game that every mission in the game we have finished all of them. And then for scene, this is basically for the map. As you can see here, plain ID, entry ID, and floor ID is like a pattern. So this is basically just like times 100 and then plus 1. Yeah, and same with floor ID, it's just times 1000. And then leader entity ID, it doesn't really matter. Just make sure that your entity ID isn't, is unique. So don't have like two entities with the same entity ID. Right now we only have the player entity, base avatar ID, which is our current lineup character, and then we have the position XYZ. Yeah, that's about it. It's okay if the UID doesn't match with this actually. In fact, let me change that back to 1. It doesn't really matter. Now let's go to player. On player, we already talked about get token. Now we have player heartbeat. Player heartbeat is basically the I'm not sure how to. Basically, it just keeps on checking on the server. It's used for the ping, like when the game like it shows like what's your ping. It uses this request. You can also use this to send Lua data to the game for the game to execute using the player heartbeat RCP proto. There's like a field for Lua, and then on player login, obviously this is for login. You give the nickname, level, stamina, word level, and all of that. And then we have like avatar. Here, this is a bit complicated. Base avatar ID is here. We are doing this is Kaelu's ID, but we want to use Stel, so you have to give Stel ID over here. You can get the ID from here. Hold up. See, girl is Stel, boy is Kaelus. Knight is like preservation, shaman harmony, memory is like remembrance, and all of that. However, if it's not March or MC, you just retype the ID. So if I have like Argenti is like 1303, I think. So you just type both of them, the same ID. Basic type ID list is like something like this. And then we have here avatar path skill tree. This is the trace. This is for I in range 1 to 9. It's just filling in the trace. That's about it. And then we have lineup. We use the same lineup for the get all and the current. So we have lineup name, plain ID. Plain ID is the same as the one in scene. And then we have the lineup avatar. HP, yeah, they use like 10,000 for maximum. So you will instead of like percent, it's something like this. Oh wait, how do I explain it better? Okay, this is normally 100%, yeah, but in Honkai Star Rail they do it like this. You use 10,000 instead of 100, and then SP bar. This is the energy of the character, and then avatar type is avatar formal type. There are other types like trial. That's about it. Yeah, I think that's all. Of course, the source code will be available, so you can just copy paste it. Okay, now I want to make the game error on purpose, so let's go to lineup. For example, I will remove the SP bar and avatar formal type. So we will just comment that and comment that out. Okay, now let's try launching the game. So let me start the server. Okay, as you can see, I am now stuck in the loading screen. When you get stuck or like any error in the game, really, what you want to do is open the game folder. Oh, no, not the game folder. Sorry, I forgot. You want to press Windows R and then type in app data. And then you want to go to like local low, Cognosphere, Star Rail, and then you can open player log. To make it easier to read, you can just copy paste it into your text editor. Now what you want to search for is no reference exception. You can use this to debug the game's error, by the way. This is what I'm doing right now. That's why I purposefully commented this out. Okay. As you can see here, we have a null reference exception regarding lineup. Get core lineup data SCRCP, which is what we tampered with. So by reading this, you can tell what is actually happening in the game and what to fix in your server. So now let's fix that by adding that back to the code, and then let's save that and restart the server, and then we can launch the game again. Okay, we are in. There you go. That's it about Honkai Star Rail private server. It's really not that hard. Honestly, I recommend just like cloning my repository on GitHub instead of actually trying to make your own, because I am such a bad teacher, so I'm sorry about that. So yeah, That's about it. See you.